Welcome to Bespoke Blogs. This blog is about electric machine design tool, Synchronous machines. Today, versatility is a reason for the working of our economy. Rising energy costs, ecological mindfulness and reliance on oil and gas sending out nations increment the inclination to foster new fuel sources and the longing to improve existing transportation frameworks. The anticipated deficiency of petroleum products and stricter emission guidelines are persuading the advancement of more effective and cleaner vehicles that burn through less and, best case scenario, no non-renewable energy source by any means. To accomplish this objective, both half-breed and full electric vehicles are important for broad innovative work in the field of vehicle innovation. Electric vehicles empower a locally outflow-free driving experience and offer a quick force thickness and great productivity over the whole speed range. The thought behind the electric powertrain is probably just about as old as the combustion engine, i.e., approximately 150 years. In the beginning of the cars, the two kinds of powertrains were conveyed. Be that as it may, the combustion engine, whose innovation and effectiveness have been logically streamlined for vehicle applications, has gotten more settled somewhat recently. The electric powertrain was, somewhat, utilized in the mechanical area and primarily in fixed applications. As needs be, improvements for electric powertrains have been made essentially as to fixed modern applications in the course of recent years. Be that as it may, the prerequisites of the unique applications in the auto area contrast fundamentally from the fixed necessities. In like manner, significant turn of events and streamlining work was and is vital on the fundamental parts of electric machines, transmissions and force hardware to change their capability to their burning partner. The electric machine, inverter and the battery structure the focal segments of an electric powertrain. Notwithstanding, more prominent consideration by and large centered around the improvement of the electric machine, since its effectiveness is ordinarily lower than that of different parts, while thinking about a wide scope of working focuses. Therefore, the focal point of this work is the plan interaction and the ensuing examination of electric machines. Notwithstanding, the point is to foster an all-encompassing model for the plan and examination of lasting magnet simultaneous machines and acceptance machines, to figure beginning plan geographies, trademark maps and empower the proficiency investigations of various machine ideas at an early plan stage. The primary focal point of the introduced device is the assessment and examination of the map and limit states of an ideal electric machine and the computation of its effectiveness. This is gainful to assess the proficiency capability of an electric machine in an early plan stage. Correlation of the simulation process of PMSM and IM. The point of the examination of the reenactment cycle of permanent magnet synchronous machines, PMSM, and induction machines, IM, is to discover collaborations between the two machine types, and carry out them in an all-encompassing model. For this reason, the individual computation steps of the plan are momentarily contrasted and one another. Fundamentals of PMSM and IM. The computation of the fundamental measurements is comparative for both machine types, PMSM and IM. The principal distinction lies in the decision of approximated values, which can be found in the predefined writing for explicit machines. In the stator plan, there are no critical contrasts that straightforwardly influence the plan cycle, on the grounds that both machine types require a twisting to produce the important pivoting field. Accordingly, the opportunities for the stator plan streamlining can be carried out indistinguishably for both IM and PMSM. The lone distinction should anyway be considered in the choice of a last winding choice, contingent upon the separate prerequisites. For instance, on account of an IM, a lower dissipating coefficient for the sounds, because of parasitic impacts is to be evaluated higher than on account of a PMSM, where the music are to be surveyed less fundamentally. The rotor configuration is generally extraordinary for the two machine types. In an IM, a winding is obliged in the rotor, which in the squirrel confine machine comprises of bars and short out rings. This must be dimensioned likewise. Moreover, the space calculation and the attractive circuit should be planned similarly to the stator plan. With a PMSM, the PMs should be dimensioned in the rotor plan and organized likewise in the rotor. Mathematical strategies are likewise needed for the exact plan and computation of IMSMs. There are additionally contrasts among IMS and PMSMs with respect to the recalculation. With PMSMs, the attention is on the assurance of the longitudinal and crossover pivot inductances and stator obstruction. Conversely, the all-out inductances of the stator and rotor, just as the stator and rotor protections, are more important for the investigation in the IM. Furthermore, the recalculation of the attractive circuit is needed to address the calculation and decide the polarizing current. Examination of PMSM and IM. On account of force control for the engine and generator model, the force control strategies are joined to shape a base current force control for both machine types. The distinction lies in the diverse framework conditions of the machines. In the IM, for instance, flows happen because of the twisting in the rotor. Moreover, the rotor pivots non-concurrently to the stator turning field. As needs be, the improvement issue used to compute the flows should be addressed with the particular framework conditions relying upon the kind of machine. Concerning the misfortune estimation, the fundamental computations between the two machine types are comparative. In any case, the various attributes of the misfortune parts should be considered. In synopsis, there are immediate cooperative energy impacts between the two machine types as to the stator plan. The stator configuration can along these lines be executed comparatively for both machine types. For the assurance of the primary measurements, the force control and the computation of the misfortunes covers in the estimations can be utilized as to certain changes for the individual machine type. In any case, the rotor plan and the recalculation are somewhat extraordinary, while no cooperative energy impacts can be misused there. Thank you for your time. Don't forget to like, subscribe and share. Do leave your thoughts in the comments section below. Please reach us at contact@thebespokediaries.com, or you can visit our website www.thebespokediaries.com.